Great. Thank you, everyone, for coming out. My name's Paul Parkinson. I'm going to be doing a little presentation on Java XR, Java with backend cloud services for VR, AR, MR, and Metaverse. I'll explain all that stuff. I am an architect and developer evangelist. So I've been programming for 40 years. I just kind of realized this the other day. And using Java ever since the day it came out, literally since it came out. So long time Java fan. And I've been dabbling in XR for a good decade or so, but the last 4 years I've been getting more and more serious training and developing with it. Here's some of my information if you want to check out my blogs or contact me. I would love to hear from you, my YouTube channel. And while I am I've been at Oracle for 20 years, technically this presentation the views are expressed are my own. Okay. And here's the quick agenda. XR overview, why Java in this space, and then some use cases and examples. Okay. So Metaverse and XR. So thanks everyone, first of all, for answering that poll. The average was 2 out of 5 stars as far as, have you done anything with XR and Metaverse? I realize this is a slightly different session in this conference. But everyone's coming from, a Java J4K background. So this is just saying what I'm not going to talk about here, because there's so much in Metaverse and XR. So first off, XR is an umbrella term that's used for virtual reality, augmented reality, mixed reality, and any immersive reality technology. So that could even be without headsets, actually. But you're probably familiar with virtual reality, which is, a complete blinding or immersion into another world. And AR and MR are pretty similar. That's, augmenting or mixing the actual world with digital overlays, holograms, or whatever the case may be. And there are so many different headsets and different technologies. Like I say, that's why it's lumped under XR. And then even worse, even larger is the term Metaverse. And this encompasses XR and many other technologies. So it's all the NFTs and Web3, blockchain, etc. So I'm going to focus on the XR aspects only. Some of these other Metaverse aspects come into that, but we're talking about 30 minutes here. I want to stay focused. So it's going to be on some of the XR aspects. And when I touch on Metaverse, it's really going to be around the concept of shared experiences and collaboration through these XR technologies. And of course, I'll elaborate on that. And then there's kind of the spectrum of XR. I'm not trying to sell it. I'm just trying to, explain some of the possibilities and use of Java Cloud in the cloud and things like that for it. But at the very least, you are seeing more and more of it. And at the very least, it uses, from our perspective as developers, it uses the same resources and services that phones do. So at the very least, XR, and in particular, wearables, it's a phone with a large screen. You know what I mean? If it's nothing else to you, it's that. But on the other end of the spectrum, and I'm closer to this end of the spectrum, and the way I see things is, it really will be. They refer to, this fourth industrial revolution of all these different technologies, of which XR is one. And, it will change. I shouldn't have used reality there, but it will change, your day-to-day activity is what it is. You stare down at a phone now, you'll stare up through glasses and interact in different ways in the future. Okay, so that's just kind of setting that. And then why cloud services? So in the mobile space, we've seen, a lot of processing move to the phone because the phone is so powerful, move that there. And of course, all the network, 5G and all that. And at the same time, we've seen more complex apps. And as I say, including, but certainly not limited to games, that rely heavily on the cloud, if not just for compute and GPU and things like that, but for services and complex logic flows. And then another way to answer why cloud services is the classic Gartner says so. This is the Gartner slide. Okay, and this is Gartner's prediction. And we see the business enablers here. Let's start from what we're talking about. Business enablers a few years out The very high circle is in AR cloud. That's what I'm talking about, cloud services for XR, AR, things like that. So you see that's pretty much in line with their prediction as well. And maybe just as interesting is what we see in the, the more near term. So we see things like advanced computer vision and IoT platforms a few years out. Well, we're already seeing this. And a lot of these technologies are what it will also be used by XR. And that's exactly what I'll show. So this all kind of lines up to that, what I'm saying and what Gartner's saying as far as the, XR in the cloud is going to be a powerful business enabler. Okay, and so here are just some common cloud services used by XR. Storage, I'm going to go into these. AI, data visualization, collaboration, just basic compute, and then it's in a way I just say all others because again there's so many use cases for XR that's so many cloud services can be used for it. So now why Java? Why it's that's the title of this presentation. Well, Java is used in XR clients. So, as an example, AR Core is an SDK used for AR development that's tailored to Android phones and things like that. However, as far as standards, WebXR provides VR and AR in compatible web browsers. These apps are generally written in JavaScript today. And then native clients, which a lot of the XR clients are written natively because they are, even though there are standards, as I mentioned here, like OpenXR, there's so many different headsets that are coming out that, basically if you're writing to a certain feature of the headset, for example, some spatial aspect or eye tracking, things like that, you're writing it to a native client, okay? Just like phones, if you're using some native features on phones, okay? And so even though there's an OpenXR standard, as I say, and everything I've written here is OpenXR standard. So all the little demos I'm going to show you now are actually all in the HoloLens, but you can run the same thing in an Oculus, for example. So this OpenXR standard has made things portable. But what's happened is Unity and Unreal are so prevalent in the development. The developers, we know what, developers hit the IDE, and Unity and Unreal is basically the popular IDE for XR by far. It's not IntelliJ or VS Code or something like that. So that's why, as far as the client piece, as I say, Java is used in clients, but that's not the prevalent. But as I just stated and Gartner stated, much of the functionality for XR is going to be in the cloud, and it is currently already. And so cloud services serve all the old purposes of phones and games and stuff, but also these new purposes of XR that I'm going into. So cloud services provide APIs, but they're generally specific in scope, right? So you're going against some kind of AI service, storage service, something like that. Java forms a nice binding and works well as a local integration layer for composable XR apps and workflows. Okay, Java is, serves it well because it's so adaptable and in using all of these services, and then as always, trivial use cases with new tech turn complicated. They turn into mission critical use cases. You need messaging, reliability, HA, transactional, et cetera, requirements. And Java is well proven, of course, in the enterprise in these areas. So if you're going to pick one language, to try and write to bind together, the one that you're going to have all the APIs for and have all of this, resilience and these features that I mentioned as far as mission critical apps, Java is an excellent choice. And then finally, it's just the Java ecosystem, along with what I just said. It's all the support in the Java system that, why we're attending this conference and things like that, right? I think I don't want to go too much into this, propping up Java, because I think most of us that attend pretty much know that the strengths of Java. It's portability, it's the fact that it's multi-cloud, so that's a big one. You write an XR solution, Java facilitates it being multi-cloud, and that's, of course, multi-cloud is very big now. extensibility, even to the point of, Panama, potentially supporting Python, which, Python is dominant in ML. Again, we have the APIs, but, Python for the ML is conceivably runnable on Java in the future. And it's well suited in microservices, serverless, et cetera, architectures, which are well suited to, getting all these disparate systems and working out a solution for a more complex app like we're talking about. So, and of course, this is the J4K conference, so hopefully everyone's familiar with that concept. So, use cases and examples. There are so many, and these are some of the more popular ones. Of course, games, architecture, engineering and construction are some of the earliest and most prevalent adopters of VR technology in particular, but all XR technologies. Remote training and assistance. A lot of these, the XR, because of the pandemic and things like that, have really, gotten more attention as well, as far as, being able to do things remotely. The conference we're doing right now, training, assistance, education, collaboration across the planet, different types of skill sets that aren't prevalent locally. The ability to collaborate and do this remote assist and training is going to be a repeated theme in the next 20 minutes that I'm talking, but in the industry in general. And as I say, education, just general workspaces, being able to have a larger workspace and different type of workspace. Telepresence, as far as conferences, telemedicine, medical, health, retail, of course, consumerism will always be one of the top ones. Spatial maps, and I'm going to go into some of these, but I just, it's a long list, and this is just the beginning of them. Data visualization, AI, ML, computer vision, and speech. That works, hand in hand with the XR stuff, and I'll go into that. Analytics, digital doubles, IoT, health and healthcare, and as I say, it goes on and on. So first one I'm going to touch on, and I'm mixing metaphors a little bit here because I'm talking about technologies and verticals kind of in the same breath. So, forgive me for that, but I'm just trying to show you as much as I can, like I say, in this 30 minutes. So just giving an example of retail and then showing you some services in the cloud that Java is accessing, and then just showing you some quick proof of concept demos and things like that, videos to go through that. So this is a basic one of, being able to select toys and play with them virtually. And what's happening here is the 3D objects, just like all the multimedia we've had before, are being stored. So the first cloud service, storage, right? You have all these new assets for 3D, sound, video, spatial anchors in space for, localized activities, shared anchors, shared local activities, all your models, and all other data. And the ability to bring this in at runtime, because you're not going to be storing all this stuff on your headset or your XR device, right? And then what we see in the second one is the concept of photogrammetry. And if anyone has a more recent iPhone or Huawei or whatever that has LiDAR enabled, you've been able to take these 3D pictures, take 2D pictures that are reassembled into 3D pictures. And so that's the storage of those, and the processing of that is another cloud service that's, has a use in XR. The other aspects of XR in retail are things, new ways of interacting. In other words, you have your Uber Eats or whatever online store, and this bottom video shows an example of that in XR, in 3D, where you can look at the food. What happened there was, the eye gaze is picked up. So that's both a different type of interaction you can get with XR, but it's new considerations for retail and sales. So that eye gaze can be recorded. And so, the interests of the participant by what they've gazed at for a certain period of time. You have these digital assets, as you saw in the first video. You can pick, just as an example, you can pick different toys and say, okay, I like these different toys. It creates a mug for you or a shirt, things like that. And then, concepts that are becoming more important for the world and for retail, such as sustainability and things like that. There's no, when you can try on a shirt instead of shipping it to you, you saved all that, the travel costs and the return costs. And if you can play with something and there's no cleanup, things like that. So I'm just giving rough examples of, different models and things like that. So moving on to another use case, which is spatial. So here we see, again, using the case of a online food delivery app. When you place the order, and then it shows you to the map and you can see where the delivery guy is coming. Same idea here, but it's a 3D map. And of course, all this is a great, as I keep giving examples of where Java is bringing these technologies together. So you have your GPS, of course, signal of the delivery, and mapped to your location, and this GeoJSON stored in a database in the cloud. And then you have your map API services, different, there are a number of those out there. And you can come up with the different spatial routing. So of course, there are a number of different spatial cases, but I'm giving one, directions, the shortest route. And that's what you see here. It's plotted out. This is multiple steps that were all taken on the server side by Java. So all we had to do was return those 3 points you see there as far as the route, and plot it out for the user to see in their XR. Okay. Another, and this is probably the most, J4K, J4K appropriate example is using this for DevOps. This may have been my first, XR application that I really wrote and put out there for people to see, and I got a great feedback because, for DevOps, you can really visualize these things as objects. So what we have here is a Kubernetes cluster, okay? And it's a namespace, and orbiting the namespace are deployments with pods, etc. And you can click on the pods to view the logs. Set up health alerts. As you can see, there's the pod is currently green. I kill the pod, it goes red, and you get an audible alert. It's just a nice visual layout. And I was, being honest with myself going into this, because I'm using this stuff every day. I'm doing the DevOps Kubernetes thing every day. Is it going to be usable? Could I actually use this? And it's really nice, even down to the logs. You bring the logs up. I was able to copy and paste. And as you'll see in the next little part of this, I set it up so that OpenTelemetry, observability, metrics, logs, and tracing were fed into the headset. And so what you see here is an actual trace going from the different microservices. And this is using REST and messaging. And I'm using the OpenTelemetry trace. And again, this is, of course, all on the server. I'm not running Kubernetes. Well, you could run Kubernetes on your headset, but obviously I'm running all this in the cloud. And it's just bringing this information back to the headset so you can visualize it and actually develop to an extent. Now, I haven't taken this as far, but I have done things where, and I don't show it in this video, where you have the one, microservices advertising its open API or async API. And then I drag a connector from one to the next. That kind of visual flow programming exists already in a number of IDs. Make the connection in that way physically, and then you can stand back and look at the microservices, and it is a nice visual representation. And I think Voodoo Barbarian on Reddit maybe said it best, which was his idea was a little more interactive. I want a VR interface that lets me build cluster elements. For example, I have a pod. I want to create a service aimed at a specific port. I want to grab that port, drag it over to another pod, and have all the service definitions and firewall rules get generated for me behind the scenes. That's exactly what I was thinking. And I've got to think if two people were, why not just do that? Why am I issuing a bunch of kubectl commands when, it's the same thing I've done, and it's just nicer. I do think it's a very feasible use case that we're going to see a lot more of. So another use case is data visualization. So what I have on the right here is two different types. I use the property graph as an example. And one of the reasons I do that is because if you're familiar with property graphs and analyze them, they're almost always analyzed by using a 3D model. And that 3D model you're viewing on a 2D screen, right? And so it makes complete sense to me. Why would you not just be using a 3D model and you're seeing it in 3D? A lot of the 2D world, some things are better in 2D, of course, to view, but a lot of the 2D world that we have is not something we chose. It's because, we're limited to screens. So if we want to see something in 3D, 3D is actual 3D is a good way to see it. So above here, I have a force layout. And on the bottom there, I have concentric layout of a property graph that shows bank transactions and is used to detect money laundering. So circular references and things like that are an indication of money laundering. And this is taken right from a graph workshop. And so in the workshop, you get graphs just like this, like you're seeing on the right here. But, like I say, by looking at it from 3D, you can identify patterns. That's just naturally how human beings work in the real world, right, with 3D. So the collaboration aspect plays heavily on this as well. And the idea of the metaverse where you're sharing this experience of collaborating. So all of these models are in the database, and all this analytics is done in the cloud, but both people that are viewing it, however many people are viewing it, can change it, and those changes are seen by any other viewer. So it's really great for collaboration in that way. And yeah, again, it brings about new use cases. A third video that I didn't include here is just grabbing raw bits of data. And some databases like the Oracle database, you can give it tables and say, find relationships between this table, form a property graph from this table. So I have another third video, I should have just put it on here, where it has just an array of data sources. So this is a table, object storage bucket, and this. And you drag them and put them onto there's a construct called a doc. Grab it and put it on the doc. And then behind the scenes on the cloud server, on the cloud service, it analyzes if there's any relationships, generates a graph like you see on the top or the bottom here, and then you can analyze it visually. So just super powerful. And, let's be honest, enjoyable. It's nice to be able to just look at things and play with them rather than, typing out, I don't know, SQL commands or whatever the case may be, where possible. Another use case, this is one of the more powerful ones, is computer vision, AI/ML in general. These are examples of computer vision, but computer speech, face, hand, body recognition, the analytics of all of this data, which this includes to a certain extent, GPT-3, language processing, all of these play very well into XR. And so what I have here is, again, a Java application that is using different cloud services. And so what's happening in this first video is the HoloLens, I'm using HoloLens in this case, takes a picture of the room, sends it to the cloud service, the Vision AI cloud service. The Vision AI takes that picture, scans it, and identifies objects in it. It gives that GeoJSON back to the Java API. The Java will then take the location of the headset when that picture was taken and send a raycast from that location through where the bounded boxes that the computer vision service created for each object, and then onto the mesh of the room. So this is very classic mixed reality use case where you're taking the actual environment and laying things onto the mesh of it. So let me just play the video. It may explain it better than my words did. This is what the viewer is seeing. So it's outlining, it's boxing, and labeling each of the objects in the room, and then speaking it back to the user. So you can see, very low processing, especially because we're doing it on the cloud. And you can see how this would be great for any number of reasons, such as like healthcare, vision impaired, Alzheimer's. Autism is used. There are a number of VR treatments for autism. It's a wide field of advantages. Military, of course. So that's an example of computer vision. And then on the bottom is another example. This is using text analysis. And so this is a little example of how you can have the headset can just be bringing in your environment, it's sending it to the cloud, and then processing it to give you back information that's contextual information about the environment. So you're in the surgery room, wherever you may be, whatever situation. In this one, I'm using a scenario where I took a picture of a bookshelf. It detects all the text, no matter what angles and stuff they're at. And then I have the text actually sent to a GPT-3 model. So I pick 4 models, and it sends back information based on those different models. And so here I'm just kind of saying, like, a scenario would be, you want to start a conversation with whoever owns these books. Automatically it brings back some context about those books. And you're like, oh, Jack LaLanne, I heard he's into juicing, and, it was his philosophy and things like that. So, but that's just an example, of course, contextual information. And, you're getting this vision and recording from the headset anyway. It's the interplay is kind of obvious and perfect for a cloud XR solution. Okay. And the last one I'm going to talk about is digital twins and IoT. So let me talk a little bit about what's going on in the demo, and that'll explain it a bit. So what I have here is a watch, and these devices collect a tremendous amount of biometrics information now. It's really amazing. So that's the IoT aspect of it in digital doubles. It's collecting that information while she's about to go. She's standing still now. She's about to go for a run. It collects that information, sends it to the server, stored in a database, and then the HoloLens picks up that information in a couple ways. One, it's viewing it through Grafana. So again, I imagine some people may be familiar with Grafana from analyzing their J4K their J4K, their Kubernetes. But it's also showing via GPS the actual activity that's taking place there. Okay, let me pause that just for 1 sec. And plotting it out there, and you can tell by the heart rate that it's the person's running. It can tell by the watch if they're inside and outside and things like that. And then you can do so many things. From your Map My Run or whatever like that, you can dump that into the system and then replay it on the map. And so you can view training. This is definitely going to be big in entertainment as far as sports and things like that. I'm already seeing that. Anyway, digital twins is creating a digital representation of an actual object or a process or anything. For example, they make digital doubles of Wi-Fi strength in a room, or a process. So that's what we see here. The other example I have is one kind of that mimics the construction, the common construction example, but it's at home control. So what you saw there was a virtual button controlling the actual light in this house. You see a photogrammetrically scanned drum is in the room, in the digital twin of this room. And then you see there in the digital twin model there, the view of the outside of the house. And I have a security camera outside the house, and that's getting fed into it. So that's, how many cloud services there. I have the streaming of the video, this that's a tricky one. Photogrammetrical image of the drum, MQTT for the control of the IoT devices, etc. And so here's another example kind of in real life where I have the security camera outside. I can, through the headset, view this video of the security camera. It looks like you're looking through the wall. Okay. So that's the actual outside view, looking through the wall. Or if you prefer, you could be looking out on the Nairobi live camera view. Okay. And so with that, I know that's a rush through, but it's really only the beginning. And I just wanted to show a few examples and show how, Java really brings it together nicely on the server side. It's a great solution. It's I kept coming back to it again and again, to put all of these demos together, use that same Java cloud service architecture. So with that, I want to thank you, and please feel free to contact me now or at any time in the future. And again, I really appreciate your time.